This video, I'm going to show you one way that you can do your work for the week. First, I'm going to review a few concepts. One of them is a little bit of vocabulary. Factors are the things you multiply together to get a product. So you can see here, factors multiplied together are equal to a product. The other concept that I'd like to review is that of place value. That's going to be important with understanding scientific notation. So place value, as you'll remember, is the value of a particular place on either side of a decimal point. So we've named all those place values. So for instance, the first one is the ones, the second one is the tenths, and the third one is the hundredths. So if you look at the chart here to the left, you can see that on either side of the decimal point, every single place has a value and a name. So below the decimal point, it's tenths, 100ths, thousandths, 10,000ths. In front of the decimal point, it's ones, tens, hundreds, thousands. And what each one of those place values have in common is, as you increase place values, it's always times 10, times 10, times 10, times 10. If you're going backwards, it's divided by 10, divided by 10, divided by 10. So that's important for scientific notation, because if we take a look at scientific notation here, you could see that scientific notation uses a base 10 as one of its factors. Okay, so I'm going to make this full screen, and we'll go into a little more detail on scientific notation. Scientific notation, you'll remember, is used to write very large numbers, or there's a very large number, or very small numbers. So here's an example of a very small number. Many place values behind the decimal point. The large number, many places in front of the decimal point. So what scientific notation is, it breaks that number down into two factors. The first factor has to be less than 10, but it has to be larger than or equal to 1. The second factor needs to be a power of 10. So the base for this second factor is always 10, and then it has an exponent that makes it a power of 10. So that's our review of scientific notation. Let's go ahead and start trying some of these problems from the homework. All right, the first one here is 32,000. And we're supposed to write that number, which is in standard notation, using scientific notation. So here's how do we do that. First, I'm going to rewrite the number so we can play around with it. So this number, the decimal point is at the end. That's where it starts out. So the first thing we're going to do in order to put it into scientific notation is decide where is that decimal point going to go when we put it into scientific notation. Well, we have to have a number that is less than 10. So if we put the decimal point right here, which is between the 3 and the 2, we know that this number is less than 10, but the other thing is it has to be greater than or equal to 1. So this one is greater than 1. 3 is greater than 1. So this first factor fits both our qualifications for the first factor in scientific notation. Now we'll put the times sign, and we can just go ahead and put a 10 there because we know that this second factor is a base 10. What we don't know yet is, what is the exponent going to be? And the way we figure that out is by finding out how many place values are there between where the decimal point originally goes and where we've put it for the scientific notation, which is right here. So to figure that out, all we're going to do is just count. We start out where it was in the beginning, and we count up to here, where we're going to put it for scientific notation. Let's count. 1, 2, 3, 4. That was 4 place values. So the exponent for the base 10 becomes a 4. And this is our scientific notation. I'll write that up here now. Original number in standard notation and our answer, which is scientific notation. Let's try this next number, which is 82,100,000. All right, so we know that the decimal point starts out here at the end. We need to figure out where it's going to go with our digits up here. It needs to be less than 10. So if we put the decimal point right after the 8, we know that it's less than 10. And if we check this out, is it larger than or equal to 1? Yes, it is. All right, so we're done with that part, and we can put our times sign, and then we'll put the 10. And now we have to figure out, what is the power of 10 going to be? So let's see how many place values there are between where the decimal point originally was and where we've decided to put it, which is right here after the 8 and before the 2. Let's count. 1, 2, 3, 4, 5, 6, and 7. There were 7 place values, so that makes this 10 to the 7th power. Now we'll take this answer and transfer it up here. All right, our last example over here is 6,000 or 600,000 for 641,000. There, I've said it. All right, our decimal point goes at the end. Where are we going to place the decimal point in scientific notation? I'll write our digits down. Well, if we put it right after the 6, that means this will be less than 10, but it's larger than or equal to 1. Then we put our times sign, and we put the base 10. Now we need to figure out how many place values are between where our decimal point originally was and where we've placed it here. So let's count. 1, 2, 3, 4, 5. There are 5 place values, so that's 10 to the 5th power. So here's our entire scientific notation, 6.41 times 10 to the 5th power. So that's the first half of this sheet. Now let's move on to the second half.